In this video, I'll point out a bit more about your actual setting out. We've talked about notation, but I do really need to emphasize when we use the notation and when we stop using the notation. Let's have a look at this. But firstly, we've been instructed to find d dx. We haven't had to decide what the notation is. The instruction is find the d dx, find the derivative of negative 1 over x to the 5. Now, that has to be something that screams out, I'm in the wrong format. X is in the denominator. X is in the denominator is not something that we have a rule for differentiating yet. So I have to use my index laws to rewrite this. So that's what I'm going to do. I'm going to say, well, the derivative of that is exactly the same as finding d dx of, and in this space here, I will write it in a format such that I can differentiate it. So it's a negative because there's the negative. It's a negative power because I'm bringing x out of the denominator and I'm putting it in the numerator. And our definition of a negative index is x to the minus a is equal to 1 over x to the plus a. So we had plus 5, bringing it to the numerator, it becomes a minus. Now, this is in the format such that I can differentiate it. So on my next line, I'm not going to write d dx because I no longer am setting it up to differentiate. In this line right here, I am going to be actually differentiating it. So this says differentiate that. I'm indicating these two lines are exactly equal. So I'm differentiating it. Minus 5 times minus x to the minus 5, subtract 1 from the index. Negative times a negative, so positive. But minus 5 minus another one is minus 6. So please take note of where I stopped with the instruction to differentiate. I had to keep it here because going from this side from the left-hand side to the right-hand side, I haven't differentiated. I still need the instruction in it at this point. However, the moment I start to do the shortcut, I am differentiating and I don't need that instruction. You're certainly going to get plenty of practice with your indices in this exercise. Have a look. Find d dx, so you're being instructed to find the derivative with respect to x of x plus 1 on x. So there's no problem with that x there, but there is a problem with 1 on x. Now, I need to rewrite just that section. So it's not like I don't need to make any change to the x, that's fine. So I still am instructed to take the derivative, or I still write the instruction, take the derivative of x plus, and using my negative index laws, I rewrite my 1 on x as x to the minus 1. In the next line, because I've set this up in such a way that I can differentiate it, I don't need the instruction because I am actually differentiating. The derivative of x is 1. Then I have a plus. I'm going to bring the power to the front of x and I'm going to subtract another 1. So I've got 1. If I'm adding a negative, it's the same as subtracting. And I've got x to the power negative 1 subtract 1 is negative 2. Be very, very careful about that. Now 1 minus x to the minus 2 can be written as 1 minus x to the minus 2 can be written using this rule here as 1 over x to the plus 2. In example 3, being instructed to find the derivative with respect to x of this little function plus this little function. They both have a problem in them. However, we have to be very, very careful. Not so much with this first one, 2 over x to the 4th. Most students do not have any problem with writing that as 2x to the minus 4. However, lots of students still have problems with this. 1 over 5x squared is equal to 1 over 5 times 1 over x squared. Now, we can leave 1 over 5 because we're not differentiating 1 over 5. It's just a number out the front. But this 1 over x squared, because we're going to be differentiating with respect to x, it needs to be written like that. You can bring the 5 into the numerator, but make sure you call it 5 to the minus 1, x to the minus 2. If you insist on bringing the 5 up out of there, which is unnecessary, you must call it 5 to the minus 1. And of course, x squared in the denominator becomes x to the minus 2 in the numerator. I'm going to work with leaving the 5 in the denominator and call it 1/5. And I will have x to the minus 2 in the numerator. So it's in a format such that I can differentiate it now, and I'm not going to keep emphasising that I don't have to rewrite d dx because I am differentiating now. I hope that you've taken note of that and you'll be able to practice it. So I've got minus 4 at the front times 2 times x. I've got minus 4 and I'm subtracting 1. Plus I have minus 2 brought to the front. I'm going to multiply it by that number, 1 on 5, and I'm going to subtract 1 from the index. I'm now going to call that minus 8x to the minus 5. And when you add a negative, it's the same as subtracting. 2 over 5, 2/5. X to the minus 3. You may be required to write that with positive indices. And if that should be the instruction, this becomes minus 8 over x to the power 5. The 8 doesn't have a negative index on it, only the x has the negative index. Likewise, we've got 2 over 5, and it's only the x with the negative index, so it goes into the denominator and it has a positive index. I'll stop the video there because the next set of examples are complicated in a different way, and so I'll deal with those in a whole nother video.